Hello once again. So we're on the second part of our midterm exam review. So we will be covering different applications of first order differential equations, and that includes growth and decay problems, interest problems, linear models. We are going to solve mixture problems, mechanics, as well as Newton's law of cooling problems. So to start with, so let's have the growth and decay. So growth and decay problem follows the law of exponential change. So that means the amount of the substance at any time t is directly proportional to the amount of substance at any time. So as long as it follows that law, so we use this formula as A is equals to C E K T, where A is the amount of the substance at any time t, so C is the proportion or is the arbitrary constant, so K as the proportionality constant, and of course T, which is for the time. So to start with, so let's solve this problem, so which is a midterm exam problem, so last second semester of school year 2022-2023. So it is a simple growth problem. So let's say in a laboratory experiment, so there were 315 bacteria initially present on a Petri dish. So after 360 minutes, so that 315, so it was observed that it increases to 865 bacteria. Okay, so for our given, so we start with 315. So initially, so when times equals to 0, there are 315 bacteria. And then after 360 minutes, so it increases to 865. Okay, so A here would be the number of bacteria. And then, so find the approximate number of bacteria after 720 minutes. So for our requirement, so we find the number of bacteria, so after 720 minutes. Okay. So we have a consistent unit of time, so which is in minutes. So that would be 720. And then find the time it will take in minutes the bacteria to increase to 3,423. So what would be the time? So when the number of bacteria is 3,423. So for our solution, so we start with A is equals to CE KT. So that is when time is equals to 0, the number of bacteria is 315. So that's we substitute it. So A is 315. So CE K, our time is 0. So thus, so this is 1, and therefore C is equal to 315. And we substitute it with our original equation. So A then will be equal to 315 EKT. And next, so we substitute the second initial value, or the second value. So that is when time is 360, the number of bacteria is 865. So we substitute it, 865 is equals to 315 e raised to, so K, and then T is 360. So we find K. So 865 divided with 315 is equals to e raised to 360K. So we take the natural logarithm of both sides, and thus giving us ln of 865 over 315 is equals to 360K. So making K to be equal to, so ln of 865 over 315 divided with 360. And finally, so we can have our working equation to be 315, then e raised to, so I'll start with T. So T ln of 865 315 divided with 360. So we can now solve our first requirement. So that is So what would be A? So when T is 720, so what is the amount of bacteria or the number of bacteria? So A then would be 315 e raised to 720. So ln of 865 over 315 divided with 360. So using our calculator, so 315 e raised to 720 ln 865 over 315 divided with 360. So that will yield to approximately, okay, so this is approximately 2,375 bacteria. Okay. So that's a multiple choice question. So the answer is 2,375. Okay, so after 720 minutes. So for our second requirement, so we are tasked to find the time, so when the bacteria are 3423. So when A is 3423, so what would be the time? So we use the formula, so 3423, so it's 315, then e raised to t, ln of 865 over 315 divided with 360. So that makes it 3423 over 315 is equals to e raised to t ln of 865 over 315 divided with 360. So take ln of both sides. So t then is equals to 360 ln of 3423 over 315 divided with ln of 865 over 315. So 360 ln 3423 over 315 divided with ln 865 over 315. The time is equal to 850.22 minutes. 850.22. So which is letter B. So this would be our final answer. So for growth and decay. So this is a very direct problem. So as long as we know the process for growth and decay, as long as we know the formula, okay, so for growth and decay, so we can easily answer such problems. So let's have the second problem. So second problem is a linear model problem. So let me add a page. Okay, so for us to solve this one. Hope that works. Okay, so don't get intimidated by this type of problems. They are easy as is. Only difference is we're just dealing with letters. Okay, so rather than numbers. So we are given a mathematical model for the rate at which a drug disseminates into the bloodstream, and that is given by dx over dt is equals to r minus kx. Okay, so x. So where r and k are positive constants, so r and k are constants, so we treat them as numbers. Okay, so those are constants. And then the function of x of t describes the concentration of the drug in the bloodstream at time t. So x would be the concentration. So how much of the drug, okay, or medicine which is present in the bloodstream at a certain period of time. Okay, so that is dx over dt, the concentration. So we are to find the limiting value of x of t. Okay, we find the function x of t. So when the differential equation is subject to x of t is equals to 0. Okay, so that is so what would be the differential equation for that? And at what time is the concentration 1/2 this limiting value? Okay, so what would be the time? So for problems such as this, okay, so it's very direct. So uh, we just simply find, okay, so we just simply find, so what is being asked, and we just solve it, okay, so we solve it directly. Okay, so for our solution, we don't have a given, so the given is the formula. So our requirements, so we start with the first requirement. So what is the limiting value of x of t? So that means at time of infinity. So what is that? The second one, so what is x of t? So what's the function for x? So given that initially, okay, so times equals to 0, so the subject to x of t is equals to 0. That means that times equals to 0, so x is 0. Okay, so that is when x is 0, or when time is equals to 0, x is 0. And lastly, what is the time required of, at what time is the concentration 1/2 this limiting value? Okay, so if the limiting value is x of infinity, so what would be the time? So when we have half of the limiting value. Okay, so half of the limiting value. Okay, so for our solution, so we start with our working equation. That is dx over dt is equals to r minus kx. So as you can see here, so this is a linear equation. Okay, so r and k are both constants. So we just simply transform it into the format of a linear equation, that is dx over dt, then plus kx is equals to r. So this is linear in x. So therefore, our p of t here is equals to k, and then our q of t is equals to r. So we find the integrating factor. So mu of t then is e raised to integral of k dt. So which make it e raised to kt. Then mu of t, so it's linear in x, is equals to q of t mu of t dt. So mu of t is e raised to kt times x is equals to q of t is r, then e raised to kt dt. So in here, our u is kt. So our du is k dt. So what we only have there is dt. R is considered to be constant. So therefore, our neutralizing factor would be 1 all over k. Thus, we have x e raised to kt is equals to r times the neutralizing factor of 1 over k, and then e raised to kt, its integral, it's still e raised to kt. And of course, plus c. So thus x e raised to kt is equals to r over k e raised to kt plus c. And we get the value of x, so by multiplying the inverse of this as e raised to negative kt. So giving us x to be equivalent to r over k plus c e raised to negative kt. And then, so what's the limiting value of x? So that is, so to get the limiting value of x when time is infinity, so what is the value of x? So we just simply substitute. So x then is equals to r over k, then plus c e raised to negative k, our time is infinity. So e raised to negative infinity, so e raised to negative infinity, that approaches to 0. So therefore, our limiting value for x is equivalent to r all over k. Okay, so x is r all over k. So as provided for the answer. So the next one is, so what would be the function of x? So when time initially, okay, so there's no concentration of drugs in the bloodstream. Okay? So we already solved so when t0, so x is 0. So we have this formula as x is equals to r over k. So by the way, so we use this formula. X is 0, so we substitute. So rk plus c e raised to negative k times 0. Okay. So this one becomes e raised to 0, okay, so which is 1. So therefore giving us c to be negative r over k. So our function then so will be x is equals to r over k, so minus r over k e raised to negative kt. Or we can factor out r over k, or x equals to r over k, so times 1 minus e raised to negative kt. So that will become the function of x, or x at any time t. Okay, so which is this one. Okay. We just factor out our k. And then at what time is the concentration 1/2 this limiting value? Okay, so at what time is the concentration 1/2 this limiting value? So if the limiting value is half of, or sorry, if the limiting value is r over k, so half of it is r over 2k. Okay, so r over 2k. So let me add another page. So space is not enough. So that means when x is 1/2 of rk, so what would be the time? So we just simply substitute. And this x is 1/2 of r over k is equals to r over k, then 1 minus e raised to negative kt. So since this is this one is an equation, so we can cancel out r over k. So that will lead us to 1/2 is equals to 1 minus e raised to negative kt. Okay, and then I'll transpose this one, e raised to negative kt, so it will become positive, and then I'll have 1 minus 1/2. So e raised to negative kt then is equals to 1 minus 1/2 is 1/2. And then, so I'll take the natural logarithm of both sides. So that would give us a negative kt. Okay. And next, so to find the time, so we divide both sides by negative k, and that would become t is equals to, this is the same as negative ln of 1/2 over k, but then ln, so this could be ln 1/2 raised to negative 1 all over k. So since 1/2 raised to negative 1, so the inverse of 1/2 is 2. So therefore, ln then, or t then will be ln 2 divided with k. So that's the time. So the unit of time was not provided. Okay, so therefore, we don't have unit for it. So but the answer is ln 2 divided with k. So this is an example of a linear model which the differential equation is given, so we just solve it. Okay, so based on the differential equation that was given. So just don't get intimidated so by letters. Okay, so it is stated naman on the problem, so which one should be treated as constant or not. Okay, so if it is treated as constant, then just treat them as constant. And that is a linear model problem. So next, we proceed with the simplest topic for the application. So which is the interest. Interest problems or interest formula is the same as the growth and decay formula. So the only difference is it's the R. Okay, so R here. Okay, so this is R, it's not K. R. So R, so which is the interest rate. So R is the interest rate. Unlike in growth and decay, so we usually solve for R. Unless, of course, it is the interest rate that is being asked by the problem. So anyway, so we use the same formula. So S would be the amount of the money at any time T. So C is the arbitrary constant. R is the interest rate, so which is in decimal form. So therefore, if it is a percentage, so we need to divide it by 100. And then T would be the time. So this is a problem again, so last semester. So for school year 2022-2023. So this is just last year. So Irene has 10,200 pesos and she is planning to deposit it on a mysterious bank. So it's a confidential bank. So where the interest is compounding continuously, so with the rate of 4.2%. So how much would be the increase from the initial amount after 5 years? So we are given that initially, so there are 10,200. And then, so it will be deposited in a bank, in a mysterious bank. So the interest rate is 0.042. Okay, so 4.2%, so divided by 100, so to make it in decimal. And then the time it would take would be 5 years. Requirement. So by the way, 10,200, so that is S of 0. So we are to find, what we are to find is not S after 5 years, but rather how much would be the increase. So it should be the increase. So the increase, so would be equal to the S after 5 years, so minus S initially. So we are already given initially, so which is 10,200. So we just need to find, so 4 S of 5. So we can use the formula. So right away, so the increase, so would be equal to SERT. Okay, so we have CERT, so minus S of 0. But then, so it follows, okay, so similar with growth and decay. So when time is 0, if S is 10,200, so therefore it follows that C is 10,200 as well. Okay, I did not derive it anymore, so that I could go right away. So with my formula, that C is 10,200, so E, the rate is 0.042, so multiply it with time, so minus 10,200. So the increase then, so will be 10,200, so E raised to 0.042, so time is 5, So minus 1. So I just factored out 10,200. So the increase then will be approximately, so do it on the calculator. So that is approximately 2,383.52. So 2383. Okay, so it's letter D. So that's a good thing if it is a multiple choice. Okay. So you can, there's already a confidence in you that you are on the right track. Okay, so that's how simple as direct as growth and decay, including interest problems, are. So let's proceed to the next, so which is the mixture. So mixture problems, so there are two formula that we are using. So for mixture problems, so we have to know this one. Okay, so in here, so we are given a solution. So inside the tank, so X so corresponds to the amount of the substance in the time at any time. So again, X usually is in a form of a mass. So V is the volume of the solution inside the tank. So which is usually measured in liters, in gallons, in cubic centimeters. So those are the parameters for the solution inside the tank. And then there's another solution that is coming inside the tank. So it could be a fresh water. So if it is a fresh water, there's no concentration on the water. Okay, so it's fresh water. So concentration then will be 0. But then, so there's a flow rate. So QI here, so it's considered as the volumetric flow rate. So how fast is the solution coming in? And at the same time, so there would be an output flow rate. So how fast a solution is coming out. But take note, okay, or rather we have another one, which is the output concentration. So output concentration is variable. So the three constants here are CI, QI, and Q out. Okay, so C out, okay, so is variable. Okay, it changes. Okay, so the concentration inside the tank is the same as the concentration that is going out from the tank. Okay, so take note that the amount of the substance at any time t, okay, so the rate of change on the amount of the substance inside the tank at any time t, so is equals to CIQI minus C out Q out. Okay. But take note that the output concentration at any instant of time can be computed as well. So that is X all over V. So wherein V is equal to the initial volume, so plus the input flow rate minus output flow rate times time. So that's how we solve some mixture problems. So there are two formulas that we need to memorize. So let's have our first example. So it states that a sewage disposal plant has a big holding tank of 1,000 or 100,000 gallon capacity. So it is filled with liquid to start with and contains 60,000 pounds of organic material in suspension. Okay. So we have a sewage disposal tank. Okay. So initially, so the capacity is 100,000 gallon. Okay, so that's the capacity, that's not the volume. So capacity is 6,000, or sorry, 100,000. But then it is half filled with liquid to start with. Okay, so if it is half filled with liquid, so that means there's 50,000 inside the tank. Okay, so initially, so the liquid inside the tank is 50,000 gallons. And then there's an organic material in suspension. Okay, so this is sewage tank. So there's something inside. Okay, so which is was it mentioned? So it is 60,000. Sorry, so it's 60,000 pounds. 60,000 pounds. And then fresh water runs into the tank. So at the rate of 20,000 gallons per hour. So something is coming in, and then the concentration is 0. So since that is a fresh water, and then it enters at 2,000 gallons per hour, 20,000 gallons per hour. And then it lives at the rate of 15,000 gallons per hour. So Q out. Is 15,000. So that's our sewage system. So in order for us to reduce the amount of organic material inside the sewage tank, so we are flushing it out. So with fresh water at a faster rate of 20,000 gallons per hour. So versus the 15,000 gallons per hour as the output rate. So after 3 hours, so are we able to, or how much organic material is in the tank? Okay, so how many were we able to flush out? Okay, so from the sewage system, but how many retains? So for our requirement, so we are just required to find, so what's the value of X after 3 hours? So it's very direct again. So for our solution, so we use our formula. dx over dt is equals to ci qi minus c out q out. But then we have our formula for output concentration. That is X divided with the initial volume. So plus input flow rate minus output flow rate times time. And of course, multiply it with the output flow rate. So we substitute. So the good thing here is the input concentration is 0. So since that is fresh water, so Qi is 20,000. So minus X, so we do not know. That's the one that we are finding. So initial volume is 50,000. So plus input flow rate is 20,000 minus output flow rate is 15,000 times time, and then output is 15,000. So this one becomes 0. So dx over dt then will be equal to, so 15,000 times x divided with 50,000. So plus 20,000 minus 15,000 is 5,000 times time. But then 5,000 is common both to numerator and denominator. Okay, so we reduce this to lowest term. So 15,000 divided with 5,000, so that is 3x all over. So 50,000 divided with 5,000, that is 10. And then 5,000 would just be t. So we have our working equation. So 2b, so dx over dt is simply equal to 3x all over 10 or t plus 10. And this one is a separable equation. Okay, so we are to find the function of x. So but make it dx over x is equals to 3 dt all over t plus 10. So this is ln x is equals to 3 t plus 10. It's still ln, so ln t plus 10 and plus c. So ln x will be equal to ln of t plus 10 raised to 3 plus c. So we exponentiate both sides, so giving us x to be equivalent to c, so t plus 10 raised to 3. And then so we need to find what's the value of c. That is, when time is equals to 0, there are 60,000 pounds of organic material inside the sewage tank. So therefore, we substitute. So 60,000 is equals to c. So t then is 0. So plus 10 raised to 3. So c will be, 1,000. So c is, sorry. So we forgot the negative sign. We have negative here. So negative 3. So negative 3 and negative 3. So when t is 0, so c then will be equivalent to 60,000. So times 1,000, that would be 60 million. 60 times 10 raised to 6. So that's x then will be equivalent to 60 times 10 raised to 6. So t plus 10 raised to negative 3. So after 3 hours, so when time is equals to 3, so what will be x then? So x then will be 60, so times 10 raised to 6. And then that would be multiplied with 3 plus 10 raised to negative 3. So 60 million, so divide it with 13 raised to 3. So approximately, so that would be 27,309.97 pounds. Okay. So X is 27,309.97 pounds of organic materials after 3 hours. Okay, so after 3 hours. And that is a mixture problem. Okay, so we have another mixture problem, so which this time it's a midterm exam problem again last year. So a tank or a large tank originally contains 200 gallons of water, so with 100 pounds of salt in solution. So water containing 1 pound per gallon of salt is entering at a rate of 3 gallons per minute, and the mixture is allowed to flow out of the tank at the rate of 2 gallons per minute. So what would be the amount of salt in the water after 100 minutes? So I'm just going to draw it here. So initial volume, so CI, QI. C out, Q out. So the tank originally contains 200 gallons of water. So there are 200 gallons of water. So with 100 pounds of salt initially in the solution. So there's 100 pounds of salt. It contains 1 pound per gallon of salt entering. So the concentration is 1 pound per gallon, and then it flows at 3 gallons per minute. It flows out at a slower rate of 2 gallons per minute. So what would be the amount of salt in the water after 100 minutes? So we are required to find the amount of salt. Okay, so X after 100 minutes. So for our solution, so we follow the same formula. So dx over dt is equal to CI QI. So minus our C out is X all over initial volume plus QI minus Q out times time times Q out. So dx over dt, our initial or input concentration is 1, Qi is 3, minus x. So initial volume is 200 plus Qi is 3, Q out is 2 times time, Q out is 2. So dx over dt then, so will be equal to 3 minus 2x all over 200 plus t. Okay, so transform this into a linear equation. So dx over dt will become plus 2 over, so I'll interchange this. So t plus 200 times x is equals to 3. So our p of t is 2 over t plus 200 and our q of t is 3. Okay, so our mu of t then will be e raised to the integral of 2 over t plus 200 dt. So which is e raised to 2 ln of t plus 200 or e raised to ln of t plus 200 square. Or simply, so t plus 200 square. So our working equation then, mu of t, so times x equals to q of t, mu of t dt. So I'll start with x, and then t plus 200 square is equals to our q of t is 3, so 3, mu of t is t plus 200 square dt. So we can use power rule here. So our u is t plus 200, so our du is dt. So therefore, x, so t plus 200 square will be equal to 3, t plus 200, so 2 plus 1 is 3, all over 3 plus c. And thus giving us x t plus 200 square is equals to, so t plus 200 cube plus c. So we can combine both. So x then will be equal to, so t plus 200 then plus c, t plus 200 raised to negative 2. So we multiply everything by t plus 200 raised to negative 2. And initially, when time is equals to 0, there's a salt, so which is 100 pounds. So x is 100. So if x is 100, initially 0 plus 200, then plus c. So 0 plus 200 raised to negative 2. So this one becomes so 100 minus 200, so it's negative 100 equals to c over 200 square. So 200 square is 40,000 times 100, which is 400,000. Or, sorry, 40,400, 4 million. So negative 4 times 10 raised to 6. That's 4c. So x then would be equivalent to t plus 200 minus 4 times 10 raised to 6, then t plus 200 raised to negative 2. So finally, so when t is 100, after 100 minutes, so what would be the amount of salt? So t plus 100, t is 100, So x is 100 plus 200 minus 4 times 10 raised to 6. So 100 plus 200 raised to negative 2. So x will be, okay, so the answer is 255.56 pounds. So that would be the amount of salt, so after 100 minutes. Okay, so let's proceed with mechanics. Okay, so for mechanics problem, so we just follow the Newton's second law, so where it states that the summation of forces, whether that is horizontal or vertical, so that would be equal to the mass times the acceleration. So usually for horizontal forces, so we are given a certain body, and then so we are given the force. So usually the amount, okay, or the air resistance and the frictional force, so opposes the direction of the force, so thus we subtract them. So for vertical forces, so usually it's the weight, okay, so which serves as the force, okay, so that is present so in the system, and then we just subtract the air resistance. So we have to take note that the acceleration is the first derivative of the velocity with respect to time. So similarly, velocity is the first derivative of the displacement with respect to time. So therefore, it follows that the acceleration is the second derivative of the displacement with respect to time. So the gravitational constant is 9.81 meters per second squared. Okay, so for metric system, and for English system, that's 32 feet per second squared. So take note that when we are talking about the limiting velocity, so that is the maximum velocity, so we're in it can be achieved when time is equals to infinity, or when velocity is constant already, so meaning it doesn't change anymore, and thus the acceleration becomes zero. So take note of this, so since we will be using this, so usually in finding the value of the proportionality constant k. Okay, so if the given problem it's not equal, okay, so rather it gives it to be proportional, then we use the limiting velocity. So in limiting velocity, so given the velocity, the acceleration will be zero. So we are given an example that a ball from rest under a resistance proportional to the square of the velocity at any instant, if the limiting velocity is 48 meters per second, so find the time required to attain half that speed. So we are given a ball it falls from rest, so that means initially, so that would be 0. So our initial position is 0 as well. So this would be the weight. So the weight of the ball is not given, but then the air resistance is provided. So air resistance is not equal. Okay, so take note, it is proportional. So therefore, it is proportional to square of the velocity. So square of the velocity. So therefore, so to make this equal, so we multiply it with the proportionality k, so v squared. So we are given the limiting velocity. So that means when time is infinity, the velocity is 48 meters per second. So find the time required to attain half that speed. So that means, so what would be the time? So when the velocity or when the speed is 24 meters per second. So for our requirement, so that's our requirement. So this is the given. So requirement is this. So for our solution, so we start with the summation of vertical forces is equals to mass times acceleration. So since this is moving downward, so therefore we're assuming that the acceleration, so that's the motion is going downward and weight is going downward, so therefore so anything that goes with the direction of acceleration, that is considered to be positive, and anything opposite that motion is considered to be negative. So in this case, so weight is going positive, so minus the air resistance, and is equals to mass times the acceleration. But then weight is not given, but we have a formula for the weight, so which is mass times the gravitational constant. So the air resistance is kv squared, and then we have the mass. Acceleration is the change in velocity, so dv over dt. Okay, so we need to find the proportionality constant k. So to do that, so we'll be able to do that so by using the idea for limiting velocity. So that is when the velocity is 48, so we have acceleration, which is acceleration or dv over dt, so which is 0. So from there, so we'll try to find our proportionality constant k. So mass is not provided, so g is constant, k. So v is 48 square. So mass is not given, acceleration is 0. So that's this one is 0, and therefore mg will be equal to 48 square is 2,304 times k. So k then will be mass times gravity, so divide it with 2,304. And then I'll go back with this equation. So mg, so this time I'm going to substitute k. That is mg over 2304. So v squared is equals to m dv over dt. And since m is common to all, so we have m here, m there, m here. So we cancel it out. So giving us this one. So I'm going to interchange. I'll start it with dv over dt is equal to g v squared all over 2304 and then minus g. And I'll factor out g. So dv over dt, so g will be v squared over 2304 minus 1. This will be a separable equation. But then, so let's try to combine. So g, 2304. So this is v squared minus 2304. So this now will become so dv did I get that one correctly? So dv over dt. Oh, so I interchanged this, so therefore so dv over dt, so I'll just have g minus gv squared all over 2304. But then I want to make v squared to be positive. So that's why I'm going to factor out negative there. So it will become, so gv squared then minus g all over 2304. So I just factor out the negative. So it will become gv squared will be positive over 2304. So minus g. And then, so minus, so 2304. I'll factor out g there. So I'll have b squared then minus 2304. So by separable equation, so this would become dv over v squared minus 2304 is equals to negative g dt all over 2304. So this is now a separated equation, so therefore we can find the solution. But then, so dv over, so v squared, so minus 2304. So it's factorable. So difference of 2 squared, that is b minus 48 and b plus 48. So remember, 2304, the square root of it is 48. So therefore, it's a difference of 2 squares. So I'll have the factor to be v minus 48 and v plus 48. I'll have a then and b. So 1 then would be equal to a times b plus 48 and then plus b minus 48. That is when a is 48, or b I mean. So 1 is equals to a times 48 plus 48, 96. So a is 1 over 96. Then when b is negative 48, so 1. So a is 0, so b would be negative 96. So b would be negative 1 over 96. So thus we'll have 1 over 96 all over b minus 48 plus 1 over, or minus 1 over 96 over v plus 48. So multiply it with dv. Is equals to negative g dt all over 2304. So this will become, so 1 over 96. So ln of v minus 48 minus 1 over 96 times ln of v plus 48 is equals to negative gt all over 2304 plus c. But then, so multiplying everything by 96, so leading us to ln v minus 48, so minus ln of v plus 48 will be equal to 96 over 2304 is negative gt all over 24. And then plus c. So combining the two, so that would become ln of v minus 48 all over v plus 48 is equals to negative gt all over 24 plus c. Exponentiating both sides, so v minus 48 over v plus 48 is equals to ce negative gt over 24. But then initially, when time is 0, so the velocity is 0 as well. So 0 minus 48 is negative 48. So 0 plus 48 is 48. Is equals to c e raised to negative 0. Okay, so c then is equals to negative 1. So giving us, So v minus 48 all over v plus 48. So to be equal to negative e raised to negative gt all over 24. So we find t. So our task is, so find the t when the velocity is 26. When v is 26, 24. 24, sorry. When v is 24, so what is the time? So I need to take ln of this, but then we cannot find the ln of a negative number, so therefore we divide both sides by negative, or multiplying this one by negative 1. So that would give us, so this would interchange 48 minus v divided with v plus 48 is equals to positive e raised to negative gt all over 24. And then I'll take the natural logarithm of both sides. So ln of 48 minus v over, so v plus 48, so will be equal to negative gt all over 24. So finally, so t then, so will be equal to 24 ln of 48 minus v all over v plus 48 divided with negative g. So t then will be 24. So ln of 48 minus 24 over 24 plus 48 divided with negative, will it be 9.81 meters per second? So it's 9.81. So our time, negative 24 ln 48 minus 24, 24 plus 48 over 9.81. That is approximately 2.7 seconds. That is our mechanics problem. It's a bit longer. But anyway, so let's have another one. So a particle of mass m is sliding down a rough inclined plane whose coefficient of friction is 0.2 and then whose height is 100 meters and whose angle of inclination is 30 degrees. If the particle starts from rest, so how long will it take to reach the foot of the plane, and with what velocity will it be traveling then? So let's say we have an inclined plane, so it's 30 degrees approximately. So this is 30 degrees, a particle of mass m. Okay, so it's just a mass m. It's not provided, the weight's not provided. The coefficient of friction, so let's say we have here the frictional force. The coefficient of friction is 0.2. So the height, so initially, so let's say the height of this, of course this is 0, so the height is 100 meters. So initially, for the inclined plane, Okay, so the uh, air resistance is not given, so therefore we're assuming that will be 0. Okay, so initially, so it starts from rest, so the initial position is 0 as well. So let's say I'm assuming that this is the weight. So this is 30 degrees. So this would be the normal force, and this would be the force F. So by the way, our requirement is, so what would be the position? So after, how long will it take to reach the foot of the plane? So how do we reach for the foot of the plane? So that is, if we have this one, so if this is 100, let's say it started at this point, and then this is 30 degrees, so therefore sine 30 degrees, so this is our S. So sine 30 degrees is S, or 100 over S. So S then would be 100 over sine 30, and sine 30 degrees is 1/2. So 100 over 0.5, so that makes it 200. So what would be the time, so when S is 200? For the second one, so with what velocity will it be traveling then? So what would be the velocity at that time? Okay, so what would be the velocity when the displacement is 200? So for our solution, so we have the summation of forces is equals to mass times acceleration. So the one that goes with the direction of the acceleration is the force, so which is just caused by the weight of the object. So minus the frictional force as the sole opposing force, because air resistance is not provided. So then mass times dv over dt. So for our force, so the force can be taken, okay, so as just simply so W, so we can use this triangle, the 30 degrees triangle. This is 30 degrees, this is the force, this is the weight. So therefore sine 30 degrees is equals to, so force times the weight. So force then will be, so weight times sine 30 degrees. But then, so sine 30 degrees is 1/2, so therefore the force is W over 2. So for the frictional force, so frictional force is the same as the coefficient of friction, so times the normal force. So we have the coefficient of friction, so to be 0.2, the Fn, so that would be W cosine 30 degrees. So 0.2 W, so cosine 30 degrees is square root of 3 all over 2. So thus this would be 0.2 over 2, that is 1 over 10. So approximately square root of 3 all over 10 W. Okay, so 0.2 over 2 is the same as 1 over 10. So times square root of 3. So thus we have W all over 2, then minus square root of 3 all over 10 times W. Then our mass is the same as okay, so mass times dv over dt. And then we have the weight, so which is mass times the gravitational constant over 2 minus square root of 3 all over 10 times mass times g is equals to m dv over dt. So again, so m is irrelevant. And this would lead us to, so we can combine the two as 10. So 10 divided so is 5, so I'll have 5g minus square root of 3g. So it's equals to dv all over dt. So dv over dt then, so will be equal to, so we factor out g, so 5 minus square root of 3 all over 10, so multiply it with g. So this is a separable equation, so dv, so 5 minus square root of 3 all over 10 g dt. So finally, v then will be equal to 5 minus square root of 3 all over 10 gt plus c. But then, so we solve, okay, so for the value of c, so that is when t is 0, so b is 0. So that's 0. And then t is 0, so this is 0 as well. So therefore, c is just equal to 0. It follows then that b is equals to 5 minus square root of 3 all over 10 times gt. But then, so we need to find the time. So when s is 200. So, but v is the same as ds over dt, right? So velocity is the first derivative of the displacement with respect to time. And then I'll have 5 minus square root of 3 all over 10, so gt. So ds then, so will be equal to 5 minus square root of 3 all over 10, so gt dt. So s then will be 5 minus square root of 3 all over 10, so gt squared all over 2 plus c. And again, so when time is 0, so s is 0. This is 0, so t is 0, everything is 0, so c is 0 as well. So thus our s, so would just be this one. So we can now find, so when s is 200, so what is the time? So this is 200 equals to, so 5 minus square root of 3 all over 10, so g t squared all over 2. So that would be, so 2 times 10 is 20, so 20 times 200, so divide it with 5 minus square root of 3 is equals to gt squared. So multiply this one by g is equals to t squared. So t then will be the square root of, so 20 times 200 divided with 5 minus square root of 3. So are these in meters? Okay, so in metric system, so I'll multiply 9.81. So 2200, 5 minus square root of 3, 9.81. So the answer is 11.17 seconds. So it will take 11.17 seconds to go to the foot of the ramp. 11.17 seconds. And for the second question is, so what would be the velocity? Okay, so at that instant. So we already have our formula for velocity. Okay, so which is this one. So So we just substitute. So that is when or when t is 11.17, so what would be the velocity? So v then would be 5 minus square root of 3 all over 10. So g is 9.81. So time is 11.17. So the velocity when it reaches the foot of the plane or inclined plane, that is approximately 35.81 meters per second. So that's how fast, okay, so the block, okay, so slides down the inclined plane. Okay, so this is a bit longer discussion. Okay. So, but that's how it goes. So lastly, so we have the Newton's law of cooling. It's the same as the growth and decay. So the only difference is there is a temperature of the environment. So that's the only difference. So we need to determine so which one is considered to be the body and which one is considered to be the medium or the environment, so for us to resolve such problem. Example, an egg whose initial temperature was 5 degrees Celsius is dropped into a pan with a boiling water. Okay, so we have an egg. Okay, so an egg is considered to be the body. And then we have the boiling water. So the boiling water is considered to be, or the pan. Okay, so pan is considered to be the medium. And then it has a boiling water. So that means we have the temperature. So water boils at 100 degrees Celsius. So therefore, the temperature of the environment is 100 degrees Celsius. So for our given, so initially, at times equals to 0, so egg is measured to be 5 degrees Celsius. So the temperature of the pan is 100 degrees Celsius. So for our requirement, so how hot is the egg after a minute? After 1 minute, so given that if it is known that its temperature increases 2 degrees Celsius in 1 second. So that means for every 1 second, there's an increase of 2 degrees Celsius. So that is after 1 minute, so that 5 degrees Celsius becomes 7 degrees Celsius because of 2 degrees Celsius increase in every minute. So for the second requirement, so how long will it take for the egg to reach 90 degrees Celsius? What would be the time? So when the temperature of the egg is 90 degrees Celsius. So for our solution, so we start with our formula, that's T minus T sub m is equals to CE KT. So initially, and time is 0, so the temperature of the egg is 5. So we substitute, so T is 5, our Tm is 100, is equals to CE K0. So this is e raised to 0 is 1, so therefore C is 5 minus 100, it's negative 95. So thus we have now T minus 100 is equals to negative 95 EKT. But then, so after 1 second, so the temperature rises to 7 degrees, so an increase of 2 degrees Celsius. So that is, so 7 minus 100 is equals to negative 95 e raised to k times 1. So this would be negative 93 is equals to negative 95 e raised to k. So negative 93 over negative 95 is equals to e raised to k. So take ln of both sides. So k then is ln of 93 over 95. So finally, our working equation would be t minus 100 negative 95 e raised to t ln of 93 over 95. So for our first requirement, that is when t is 1. Okay, so what would be, or after okay, sorry, so this one is a minute. Okay, so after a minute, so our reference time, so for the problem, is in seconds. Okay, so therefore we change the 1 into 60. Okay, so instead of 1, otherwise we'll get 7. So we write, so after 60 seconds, so when t is 60, so what would be the temperature? So t then is equals, or t minus 100 is equals to negative 95 e raised to 60 ln of 93 over 95. So t is equals to 73.5 degrees Celsius. And finally, that is when the temperature is 90 degrees Celsius. So what would be that time? So it should be greater than 60 seconds or greater than a minute. So 90, so minus 100 is equals to negative 95 e raised to t ln of 93 over 95. So 90 minus 100 is negative 10 divided with negative 95 is equals to et ln of 93 over 95. So take ln of both sides. So t then would be ln of 10 over 95 divided with ln of 93 over 95. So finally, it would take 105.81 seconds so to achieve that 90 degrees Celsius of a temperature. And that is all. So I do wish you well, okay, so for your midterm exam, and I hope you all pass. Good day and God bless always.